Hey guys, we're back in Welch's math class. We are picking back up on some geometry. We are still in really section 8.1, 8.2, some of the basics of geometry, and we're going to carry on a little bit with a little bit more about lines and angles. So where I want to start right now is I want to talk about some relationships between some different lines. For example, I want to talk about something called P-A-R-A-L-L-E-L lines, parallel lines. Okay? Parallel lines run side by side, but never, let's try to make that a little better, never touch. Okay? And it's not exactly true to say they run side by side but never touch. They actually may be quite a distance away from one another. The key is they keep the same distance apart at all points on each line. They never get any closer together. They never get any farther apart. Now it's easy to see if we go ahead and put them up here side by side. So if I have a line and then I come with another line that sort of runs side by side, okay? And of course I can't draw a perfect parallel set of lines here, but just imagine for a second that these two lines at no point ever got any closer than whatever the distance is between them. That would make them parallel lines. They never cross, they never touch each other, they never get any closer to one another, they never get any farther apart from one another. So we could label this line A, B, and let's say we label this line X, Y. What we would come in and say then is line A, B is parallel to line X, Y. That's the symbolism that we would come in and use to let us know that what we mean to say, even though my drawing is horrible, what we mean to say is that these lines are parallel. They never cross each other, they never touch. That's what we mean by parallel lines. Alright, so from there, let's go on and grab hold of this concept of what happens when lines do touch. Well, if lines do touch and actually cross one another, these would be called intersecting lines. Intersecting lines. Now notice when they intersect, they actually form 1, 2, 3, 4 angles. Now for the sake of simplicity, I'm going to label these angles that we have here. I'm going to label this one angle 1. I'm going to label this one angle 2, angle 3, angle 4. It's a little simpler in this situation to label them just by the numbers that are in there. Those are not the measures of the angles by any means, but it's a little simpler to see the measures. So the thing I want to get across here is these intersecting lines, they cross and they form these angles, okay? 1, 2, 3, 4, and a couple of things I want to say about these angles, okay? So we have angle 1, which is opposite, okay, opposite to angle 3. And opposite angles actually are equal to one another in terms of their measurement, okay? Angle 1 equal opposite 3, or excuse me, equal angle 3. These are opposite angles. So we know we can say really the same thing about angles 2 and 4. We can say angle 2 equal angle 4 equal angle 4. Again, these are opposite angles. Alright, so there's a characteristic of when we have intersecting lines that they will form opposite and equal angles, just like so. Alright, intersecting lines, characteristic of those. Moving on from there, and by the way, if you're not keeping up with me, just pause the video, capture your stuff. You want to get all this in your notes for sure. Good information that's going to really be helpful to you. as you work through your homework problems. Now, if we have two intersecting lines that cross like so at a right angle, okay, let's call this actually line ST. Let's call this line CD, okay? Now, when they cross at this right angle, this 90-degree angle right here, these are actually known as perpendicular lines, okay? Perpendicular lines, perpendicular lines, intersect as right, that is 90-degree angles. All right? So the way we would write that up to represent that, we would come in and we would say line CD is perpendicular to, that's my symbol for perpendicular, perpendicular to line ST. The line symbol over the top of that. All right? So those are perpendicular lines. Perpendicular lines. All right. Moving on from there. Capture that? Got it? Hope so. You can pause the video. You know you can do that. So no problem. I'm just rolling along here, having a good time. All right. So the next thing I want to talk about are something called complementary angles. Okay? Let's give you a definition first here. Complementary. These are angles that say good things about one another. They really complement one another all the time. Not really. Not really. Complementary angles. Had you go in there for a minute, huh? No? Okay. Complementary angles, no, they're not nice to one another. Complementary angles come together to form a right, that is 90-degree. Remember, when we say right angle, we mean 90-degree angle. They come together to form a right or 90-degree angle. So two complementary angles, two complementary angles come together to form a 90-degree angle. So if we're drawing it, let's draw ourselves this nice right angle here, and let's just do this and put another angle in it. And let's just kind of pretend like this one right here is 40 degrees, and this one right here is 50 degrees. Okay, we'll label these angles. Okay, A, B, C. Now let's call this one C, and let's call this one D. So what we can say here is angle D. Ooh, it's funny when you say D and write B, isn't it? Angle DBA is, let's change that. Angle DBC. Angle DBC here, right here, this angle, is complementary to angle, how about CBA? We can see it visually here that they form the 90-degree or the right angle, but we can also see it through mathematics of simple arithmetic. 50 plus 40 is 90. 50 plus 40 is 90. So complementary angles come together to form a 90-degree or a right angle. That's what's happening with complementary angles. So just a quick, just mathematical situation here. We could say the complement of a let's say 72-degree angle is an 18-degree angle. All right, is an 18-degree angle, because 72 plus 18 is 90. So if I ask you, what is the complement of a 45-degree, I don't want to say 45, a 47-degree angle, then I hope you would know that to do that, you would do 90 minus 47. 90 minus 47 equals 43. So the complement of a 47-degree angle is a 43-degree angle. That's complement. Okay, now from there we want to say a quick word about supplementary angles. Okay, so supplementary angles, S-U-P-P-L-E-M-E-N-T-A-R-Y angles come together to form a straight, that is 180-degree angle. Okay, let's draw that first. Let's draw a straight angle. Notice that straight angle right there. Measure of the straight angle is 180 degrees. Okay, now let's shoot off of that right here. Okay, so what we've got at this point, I'm going to guess this angle right here is about 40 degrees. So its supplement would be over here. The supplement would, to get 180, would be 140 degrees. Okay, these two angles are supplementary to one another. All right, these two angles are supplementary. That's not good. Let's just say it this way. The supplement of a 40-degree angle is a 140-degree angle, because together they make 180. All right? Cool deal. Good deal. So we've talked a lot about those things. Now I want to give you one last thing here, just a brief minute, a problem from your homework that I think we can give you some help with. All right? You're going to have this problem in your homework that looks like this. Okay? We're forming all these angles. Now I'm going to label these angles 1, 2, 3, 4, 5, 6. Okay, so I'm seeing 6 angles here. 1, 2, 3, 4, 5, 6. Now I want to give you the measure. If I give you the measure of angle 1, and I say that angle 1 here, let's make it, I don't know, what would be a good measure for that? That looks like that's probably about 55 degrees. Let's call that 55 degrees. Let's go ahead and call angle 2. Let's give you a measure for angle 2. That looks like that's probably about 100, let's call that 115 degrees. Okay? And then we want to know what's the measure of angle 3, of angle 4, of angle 5, and angle 6. We're going to use a couple principles here to run into this just very quickly. Angle 4 is opposite angle 1. Angle 4 is opposite 55. All right, right here, angle 2 is opposite angle 5. Makes that 115. 115. Now, finally, when you take angle 1, 2 together and put them with angle 3, you have a set of supplementary angles. The 115 and the 55 together, these two together, are going to get me 100, maybe 170, okay? 20, yeah, 170. So that leaves, out of 170, if these two together, right here, are 170, that leaves 10 right here, which means this opposite angle here is also 10. So from two angles, I can get every angle on the thing. All right, guys, well, that's all I got for you right now. Looking forward to next time we get together, we'll talk again about some geometry. Have a great day. Get into some homework. Thanks.